In this session, we shall continue to go through some more important concepts and their usages, derivations like formulas, etc. Okay, we recall the famous Wallis formula in definite integrals, that is integral 0 to pi by 2 sine power nx dx. If you name it some in, this is integral 0 to pi by 2 cos power nx also. How and why? In the place of x, you replace pi by 2 minus x. Sine pi by 2 minus x is cos x. And this can be simplified as n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into and so on. At last, I0 if n is even, I1 if n is odd. Of course, what is I0 and I1? You have named it some in. What is meant by I0? What is I0? Integral 0 to pi by 2. Come on. Sine power 0x is 1, hence it is nothing but pi by 2. What is I0? Pi by 2. Integral 1 is x. X between the limits is 0 to pi by 2 is pi by 2. And I0 is equal to pi by 2. Again, what is meant by I1? I1 is equal to integral 0 to pi by 2. In the place of n, you take 1. What happens? Sine power 1x is nothing but sine x. Its integral is minus cos x. Minus cos x between the limits 0 to pi by 2. Minus cos x between the limits 0 to pi by 2. Cos pi by 2 is 0. Cos 0 is 1. Minus of 0 minus 1 is 1. Hence, I1 is 1. You please notice the pattern or the methodology of putting these factors. Starting step is n minus 1 by n. Go on decreasing 2 in the numerator as well as in the denominator. You see, as n is finite, there might be an end. And at the end, if n is 0, you put I0. If n is even, put I0. And if n is odd, put I1. Of course, I0 is pi by 2 and I1 is 1. Well, let us observe the applications of this theorem. You consider the problems. Integral 0 to pi by 2 sine power 4x. What is n? 4. N minus 1 by n is 3 by 4. 4 minus 2 is 2. Can you still decrease? No. Here it becomes 0. Now you think of, is n even or odd? It is even. Therefore, you take I0. I0. What is I0? We could have already found. It is pi by 2. Hence, the answer is 3 pi by 16. 3 pi by 16. One more problem. You take I5 is equal to integral 0 to pi by 2 cos power 5x. We have considered an example of an even power n. Here we have taken an odd power. Let us see what happens. The starting step is n minus 1 by n. Come on, 2 by 3. Can you still decrease? No, you cannot decrease. Why? Because 2 minus 2 becomes 0. You stop there. As n is odd, we put I1. And by I1, we mean, what is I1? It is 1. Hence, it is 8 by 15. 8 by 15. One more. You consider I10 is equal to integral 0 to pi by 2 sine power 10x. What happens to the answer? I10 it is. What is n? 10. It is 10. Starting step is n minus 1 by n. Come on, proceed. 7, 5, 3, 1. Stop. 8, 6, 4, 2, stop. You cannot still decrease another 2 because in the numerator it becomes negative and in the denominator it becomes 0. So it's not possible. You stop there. Well, what is n? Even. Hence you have to take I0. But I0 is of course pi by 2. Meanwhile, you can cancel some things here. Any possibility to cancel? There is only one possibility. 5 goes. How many times? 2 times. 3 goes. 2 times. Any more cancellations? No more cancellations. So this is into I0. What is I0? Pi by 2. What is I0? Pi by 2. Hence this is 63 by 512 pi. This is the answer. Whatever might be the value of that n, either it is even or odd, we will be able to have the answer like this. Okay, next one. You observe the case integral minus pi by 2 to plus pi by 2 sine power 8x. My dear friend, in order to make use of Wallis formula, the limits must be 0 to pi by 2. You see, here it is not such, it is minus a to a. Well, you observe this function. Is it even or odd? It is an even function, isn't it? Therefore, let us recall this formula. What is that formula? Integral minus a to a f of x dx is equal to, come on, let us recollect the formula. Integral 0 to a f of x dx, provided f is even, and is 0 if f is odd. I think you could have recollected the formula. Come on, sine power 8x is an even function. Therefore, we have the right of getting 2 before and write it as 0 to pi by 2 sine power 8x dx. Well, we should feel happy, but because this has been thrown into the standard form, that is Wallis formula, integral 0 to pi by 2 sine power nx. In the place of n, what are you having here? 8. Hence, come on, simplify. What is the starting step? N minus 1 by n. 5, 3, 1, 6, 4, 2. Stop. Into, what is 8? It is an even number. So as it is even, we have to take I0 at the end, isn't it? I0. Well, you cancel 1, 2 and 2. Any more cancellations? 3 goes 2 times. Any more? No more. Altogether it is 35 by 2 cube. 2 square. You see? 2 plus 1, 3 plus 3, 6. That is 2 power 6 into pi by 2. Here, because I0 is pi by 2. Altogether, the answer is 35 pi by 2 power 7, that is 128. This becomes the answer. Well, my dear, in this problem, integral minus pi by 2 to pi by 2, if at all, sine power 23x is given. How to get it simplified? My dear friend, you notice that this is an odd function. The formula is just beside our site. Yes, you can observe, as this is an odd function, no question of any more simplifications, and the answer is 0, of course, for this. It is simply 0. Okay. Well, let us observe one more example of this sort. Integral minus pi by 2 to pi by 2 cos power 7x dx. My dear friend, 7 is an odd number. Even then, cos x is an even function, you see. So, cos power 7x is also an even function. Hence, as it is an even function, you can split this as 2 into integral 0 to pi by 2 cos to the power of 7x. Well, my dear, this is in the standard form of I7, isn't it? Instead of in, we have I7 here. Well, let us simplify with the usual procedure. What is that usual procedure? Starting step, come on. N minus 1 by n. What is n minus 1? 6 by n. 4, 2, 5, 3. Okay. This is add. 7 is add. So we have to take I1 at last. Any more cancellations? 3 goes 2 times. That's all. There is the only cancellation. 2 2s are 4. 4 4s are 16. 16 2s are 32. Answer is 32 by 35 is of course the answer. Of course you can ignore I1 because I1 is 1, as we could have already noted it. I1 is 1, hence the answer is 32 by 35. Well, you observe another such question. Minus pi by 2 to pi by 2 cos power 6x dx. As and when you are dealing with the cosine function, basically cos x is an even function. Therefore, irrespective of the exponent attributed to that, either it is odd or even, no problem, it is an even function. Hence, it can be taken integral 0 to pi by 2 cos power 6x dx. Well, 2 into cos power 6x. Again, it is in the standard form of I6, isn't it? Instead of IN, we have I6. Come on, what is the starting step of simplification? N minus 1 by n. 3, 1, 4, 2 into, this is even, isn't it? I0 is preferred because 6 is even. But we of course know that I0 is nothing but pi by 2. Good. This goes 2 times. This 2 and this 2 will go away. Altogether this is 5 by 8 into what is I0? Pi by 2. Hence the total ultimate answer is 5 pi by 16. In this way, we make use of Wallis formula. Even though it is not in the standard form, we of course bring it into the standard form. Let us now observe one more occasion in which it is needed to bring it into the standard form. Now you consider the question integral minus 2 pi to 2 pi sine power 8x. Minus 2 pi to 2 pi sine power 8x. Again, we may have to recall the previous formula, that is integral minus a to a f of x dx. What happens to that? If the function inside, in the place of integrand, is an even function, you may have to write it as 2 into integral 0 to, isn't it? Of course, sine power 8x is an even function. Hence, you can write this 2 into integral 0 to 2 pi sine power 8x. What is the reason? Sine power 8x is an even function. Well, now, it is not in the standard form of Wallis formula. If you want to use Wallis formula, it must be 0 to pi by 2. It's not the case. It is from 0 to 2 pi. Well, now at this juncture, we recall another standard formula. I like to quote it on the board. Integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x. Otherwise, 0 if f of 2a minus x is equal to minus f of x. This is also one of the most useful formulae. Now, it is our need now to use it. Come on. You call this f of x, f of 2a minus x. Sine of 2 pi minus x. What is that? Sine of 2 pi minus, it is in the fourth quadrant, minus sine x. But you see, luckily we have the exponent 8. Hence, f of 2a minus x is f of x. So, which case is to be applied here? Either the first case or second case? The first case. Hence, we can get 2 out. 2 into integral 0 to pi sine power 8x dx. Again, in the place of 2a, we have pi, of course. Sine of pi minus x whole power 8. Any changes? No change. Sine power 8x itself. That is f of 2a minus x is equal to f of x. The first case is to be applied here also. Hence, you can pull and one more 2 into integral 0 to pi by 2 sine power 8x. Now, at this moment, we should feel happy because this has been converted into the standard form of Wallis formula, that is integral 0 to pi by 2 sine power nx. In the place of n, what are you having here? 8. Hence, it is nothing but I8. 4 into, what is I8? What is the starting step of simplification? 7 by 8, 5, 3, 1, 6, 4, 2. Into I0. Why should you have I0? Because n is even. What is I0 actually? Pi by 2. Hence it is pi by 2. Any more cancellations? Of course, there are some cancellations. You can cancel 4 and 4. You can cancel 3. Any more? No more at all. 7 into 5, 35. 35 pi by, come on. 2 2s are 4, 4 2s are 8, 8 8s are 64. Then the answer is 35 pi by 64. See, even though the function is not in the standard form, we can bring into the standard form of Wallis formula to have the simplified answer like this. Of course, meanwhile, we shall make use of some more results like that. Well, my dear friend, in this problem, if it are instead of sine power 8x, if minus 2 pi to 2 pi sine power 11x is asked, of course, what will be the way of thinking? Well, my dear, sine of 2 pi minus x is minus sine x. Minus sine x whole power 11 is minus sine power 11x. So, in that box, you are supposed to apply either the first case or the second case. The second case, hence the answer is 0. Mercilessly we put 0 because sine power 11x changes sign in fourth quadrant, isn't it? So, sine power 11x, sine power 11 of 2 pi minus x is nothing but minus sine power 11x. Hence the answer becomes 0 in the very first step itself, isn't it? In the very first step itself, it is 0. Another formula, another problem, another application of that one is integral minus 4 pi to 4 pi cos power 7x dx. First of all, is this function an even function or odd function? Cos of minus x is nothing but cos x, isn't it? So it is an even function. Irrespective of the exponent present here, this is surely an even function. As it is an even function, by encashing the formula integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx, provided f is even. F is even. Okay, cos power 7x is an even function, hence we can write this as integral 2 into integral 0 to 4 pi cos power 7x dx. Now, this is the time for us to use that formula. In the place of 2a, we have 4 pi. Come on, consider f of x is cos power 7x. What is f of 2a minus x? Cos of 2a minus x to 4 pi minus x whole power 7. 4 pi minus means fourth quadrant. In the fourth quadrant, cos x is positive. Positive power 7, it is again positive. So, no more changes at all. So, you decide either the first case here or second case that is to be applied. Which is to be applied? The first case, because we could observe no change at all if you consider f of 2a minus x, isn't it? Well, and we can pull one more 2 so that it becomes 0 to 2 pi cos power 7x dx. Again, it is to be repeated. In the place of 2a, we have 2 pi. Consider cos 2 pi minus x. What is cos 2 pi minus x? 2 pi minus fourth quadrant is positive. No problem. power 7 is again positive. So there are no changes at all. Hence we can pull one more 2 out. 2 into 2 into 2 into 0 to pi cos power 7x. Again, at this juncture also, we are supposed to apply that box, that is that formula. Come on, in the place of 2a, what are you having? Pi. What is cos of pi minus x? Cos of pi minus x. Each quadrant, second quadrant. In the second quadrant, cos function is negative. So cos of pi minus x is minus cos x. Minus cos x whole power 7 is minus cos power 7x. Hence, the second case is to be applied. Hence, it is 8 into 0 is 0. You may feel something about the way of simplification. Oh, we have done 3 or more steps, at the last the answer has become 0. We cannot help. Its nature is like that. Hence the answer is 0. Okay, right. There are some more standard results which we come across in our way of solving so many numerical problems, that those standard results can be used as formulae also. Let me bring to your notice one of such. Integral a to b square root of x minus a by b minus x. Integral a to b 1 by root of x minus a into b minus x. Integral a to b root of x minus a into b minus x dx. Well, these three these three problems look alike. All these integrals have been constructed between a and b only. And the expressions involved in these are x minus a and b minus x. You please observe x lies between a and b, that is a less than x less than b. So x minus a is positive and b minus x is positive. You would have gathered the positive quantities as expressions here. And it is quite necessary to use the answers here. And this is a pi by 2 into b minus a. This is pi. This is pi by 8 into b minus a whole square. Three important answers which look alike. You may have to be very careful about them. Let us, and they will be remembered only when and only when you solve as many problems as you can and as you want. Let us start. As the question is given as -1 to 1, you may have to test, you may wish to test whether it is an odd function or an even function. You observe it is neither even nor odd, so you cannot encash that formula which we have discussed previously. Well, a to b, x minus a, x minus of -1, x plus 1, 1 minus x. So the answer is pi by 2 into b minus a, that is 1 minus of -1, 1 minus of -1, hence the answer is pi. You can verify this also. This is -1 to 1 square root of 1 plus x by square root of 1 minus x square dx. Isn't it? 1 plus, because I could have multiplied with the numerator and denominator with root 1 plus x. So this can be split again into two integrals. -1 to 1, 1 by root of 1 minus x square dx, plus -1 to 1 x by root of 1 minus x square. This is 1 by root of 1 minus x square is sine inverse x between the limits -1 and 1, plus this is 0. Why is it 0? Why is it 0? Come on, imagine. Why is it 0? It is 0 because this is totally an odd function. Denominator is an even function, numerator is an odd function, so the quotient is an odd function, and integral minus a to a f of x dx vanishes when f of x is an odd function. Isn't it? If f of x is an odd function, we have noticed that minus a to a integral f of x dx vanishes. Therefore, that is 0. Well, this is sine inverse 1 minus sine inverse minus 1. Sine inverse 1 is of course pi by 2, and it is of course minus pi by 2. Pi by 2 minus of minus pi by 2 is pi, which is obtained in the beginning itself, isn't it? Therefore, you can encash the formula integral a to b square root of x minus a by b minus x dx is nothing but pi by 2 into b minus a. Well, so what is the formula we have just now used? Integral a to b square root of x minus a by b minus x dx is therefore equal to pi by 2 into b minus a. Another application of the formula integral a to b root of x minus a by b minus x dx, we shall look at integral 2 to 3 integral of x minus 2 by 3 minus x dx is, answer is, you see, if you do not know that formula, it will be a tedious job. Why? Because you may have to rationalize the numerator, that is, you may have to multiply with x minus to both numerator and denominator. A quadratic will be obtained in the denominator. You may have to use the perfect squaring method and so on. It is a laborious process, of course, but we do not come across such things in this answer. Come on, it is a to b x minus a by b minus x, hence the answer is, come on, pi by 2 into b minus a, hence the answer is pi by 2. Well, do you have any intention to know the way of proving that result? Well, okay, if you want to have the proof, a beautiful famous standard substitution is there. X is equal to a cos square theta plus b sin square theta. With that substitution only, not only this one, the other two, that is integral a to b root of x minus a into b minus x and integral a to b 1 by root of x minus a into b minus x, all those three can be directly obtained by using the standard substitution. X is equal to a cos square theta and b sin square theta. Of course, like this, we will be making use this formula. Another application, integral of minus 3 to 5 square root of x plus 3 by 5 minus x dx. Come on. The thing is, you may have to notice it that this is in the standard form. In the place of a, we have minus 3, and in the place of b, we have 5. X minus a means x plus 3 by b minus x, 5 minus x. Excellent. This is thrown into the standard model. Hence the answer is, come on, pi by 2 into b minus a. That is 5 minus of minus 3, 8. 8 by 2 is 4. Hence the answer is 4 pi. The answer is 4 pi. And one more, integral 0 to 5 square root of x by 5 minus 6. Come on, tell me, what is the answer for this? Oh, it is 0 to 5. It's not in the standard model. You may have a doubt of that. No. You observe it carefully. In the place of a, we have 0. And in the place of b, we have 5. Come on, x minus a. What is x minus a? X minus 0. That is x, of course. And b minus x is 5 minus x. So, exactly and absolutely, this problem is also in that standard model. Therefore, you can make use of that answer here also for this question. Come on, imagine what is the answer? Pi by 2 into b minus a. That is 5 pi by 2. The only thing is, you must be able to notice that it is in the standard form. Yes. If you can do that, you can read the answer on the spot within 5 seconds. This is the nature of that formula. Let us now concentrate on Another formula. Well, integral 1 to 2 square root of x minus 1 into 2 minus 6. Answer please. It is very clear to observe that it is in the standard form. In the place of A, we have 1. In the place of B, we have 2. So the answer is pi by 8 into B minus A whole square. Hence the answer is pi by 8. Pi by 8. Another formula in another problem. Integral 0 to 3 square root of x into 3 minus 6. Come on. As we could discuss just now, in the place of A, we have 0 here. A minus x, no sorry, x minus z, that is x into 3 minus 6 we have. If you do not know that formula, then you may have to get this as a quadratic expression, and which is to be, of course, made a perfect square by that methodology, and you may have to use a formula of root a squared plus x square root of x squared minus a square, like that. Surely it is a tedious job. Of course, we do not do that. We do not do that. Hence, the answer is pi by 8 into b minus a whole square. That is 9 pi by 8. 9 pi by 8. Integral minus 2 to 3 square root of x plus 6 minus x square. You may get a doubt. Is it in the standard form or not? You obtain it. How to get that observation? You try to factorize this. What are the factors for that? Minus 2 to 3 square root of minus of x square minus x minus 6. Am I correct? You don't feel anything that minus negative symbol is there inside the square root. Besides that, another quantity is also there, which I'll look after, don't worry. This is equal to minus 2 to 3 integral of root of, it is x minus 3 into x plus 2. Isn't it? Well, this again takes the form minus 2 to 3 root of x plus 2 into 3 minus x. Now you observe the shape of this integrand. Root of x minus a into b minus 6. Does that shape does it acquire or not? It has acquired. Therefore, we will be making use of the formula. What is the formula? This is nothing but pi by 8 into b minus a whole square, isn't it? What is 3 minus of minus 2? 3 plus 2, 5. 5 square is 25. Hence, the answer is 25 pi by 8. 25 pi by 8. So, if at all the given problem, in the given problem, the integrand is not in the standard form, by hook or crook, by factorization or any other material, any other source, you can bring that into standard form, so that the answer pi by 8 into b minus a whole square can directly be used, of course. You imagine how beautiful it is, how useful it is. Yes, let us see one more such question. Imagine integral 1 to 3 square root of 4x minus 3 minus x square. Yes, I think you need not put the steps. You can directly have as x minus 1 into 3 minus x, isn't it? Why? Because if you get minus common, x square minus 4x plus 3 you will be having, it's nothing but x minus 4, x minus 1 into x minus 3. Of course, this is. So, no problem. Hence, this formula can directly be used here. What are you having in the place of A? 1. And in the place of B, we have 3. So the answer is, it is readily available in the box on the board. What is that? Pi by 8 into b minus a whole square. 3 minus 1 is 2. 2 square is 4. 4 by 8 is, it is pi by 2 is the right option. Is the right answer. So that is the utility of this formula. Another thing is also there. Integral of 1 by square root of x minus a into b minus x dx between the limits a to b is just nothing but pi. Just nothing but pi. As if it lies in the denominator, well, you tell me the answer. Integral 2 to phi dx by root of x minus 2 into phi minus x. Come on. This problem directly is given in terms of the standard form, isn't it? X minus a, b minus x, a, b. So the answer is simply pi. See, it is in the denominator. If at all this entire expression comes to the numerator, then what will be the answer? Pi by 8 into b minus a whole square, that is pi by 8 into phi minus 2 whole square, that is 9 pi by 8 becomes the answer. No, it is not in the numerator, it is in the denominator only. Hence the answer is simply pi. Well done. One more problem. Integral minus 1 to 0, integral minus 1 to 0, no, integral minus 1 to 3, 1 by a root of x plus 1 into 3 minus 6. What is that? In the place of a we have minus 1, in the place of b we have 3. X minus a, that is x minus of minus 1, and b minus 6, that is 3 minus 6. Again the answer is, come on, pi. Okay, one more thing. Integral of integral 0 to 1, 1 by a root of x into 1 minus x. Come on, what is the answer? X minus x square, of course. The answer is again pi. Well, this formula and the previous formula, that is integral a to b root of x minus a into b minus x dx is equal to pi by 8 into b minus a whole square, and the very first formula of this sort, integral a to b root of x minus a by b minus x dx, all these formulas can be derived by using a standard substitution. It's pi by 2 into b minus a only, not whole square. By the standard substitution, x is equal to a cos square theta plus b sin square theta, and by changing the limits accordingly with respect to theta. Like that. These three formulas become very standard, popular and useful because they can be used at so many instances. Yes, that's it about these three formulae.